There is so much drama around this bricklayer printing, but it's time to find out, is it worth it? Welcome back. So what are these bricklayers? Well, it's an expression which is used nowadays for printing method where line of the walls will not be in the same plane, but every second line will be moved by half layer, and with this we have some better interlocking between these lines. Now maybe this is not the best expression because unlike with the brick walls, we don't have this shift in horizontal direction but in vertical direction. But this is exactly what we need, and Stratasys calls it hexagonal pattern layers or something like that, where we have the locking with the 6 neighbors around the line. And now I mentioned 4 YouTube channels. The first one is the CNC Kitchen. He did some first testing with the layer adhesion mostly, and he noticed some increasing in the strength, and basically he invited others to do this testing if they can. The second channel is the Geek Tour. He noticed that there is an existing patent for this printing method, but probably it shouldn't be valid because there is an older one by Stratasys which actually expired. And the third one is the TenTech. He created a Python script which can be integrated, and together with the PrusaSlicer or OrcaSlicer, on the output it can modify the G-code and save it with these brick layers integrated. And the fourth channel is My Tech Fun, as the one which are you looking now. And I want to use this method developed by TenTech, and I want to print these test objects and to see if we have some increasing in strength, not only in layer adhesion, but maybe in some other direction, if this works correctly. Because there is an important thing I didn't mention. If we move that second lines of the wall, in that case we have more space in that gap, and we can increase the multiplier, and I believe that we can improve the strength in all directions, not only in layer adhesion. It's Igor from the future. A small correction, not just we can increase this multiplier, but we must increase it, and soon you will see why. So I will use this Python script with the PrusaSlicer and Prusa Mark IV. Everything is described on TenTech channel how to use this script. One thing I would add, if you are using the Windows, don't forget to enable those 2 checkboxes, otherwise you will get an error code 9009. It took me some time to figure out what is the problem. Now the script is not really perfect yet because the printing order is not good. I mean, more logical would be to print all lower layers and then all those layers lines which are moved by the half layer. But this printing order is the same for like with the regular printing, from inside to outside, and because of this I'm expecting some bigger side force during the printing created by the nozzle, and this may be a problem with some taller objects. So just in case, usually with the PLA I'm not using the bed adhesives, but here I am using the glue stick. This script modifies only the walls and not the infill, but in my case I'm using the maximum number of the walls anyway with my test objects. And also the last top surface is not so nice like with the regular printing, because we can see this compensating. Maybe some kind of ironing on the top layer would be nice, but for my testing it is not important. The material we use for this video is the Prusa PLA in grey color, and all test objects will be printed on Prusa Mark IV. These are the brick layers, and this is regular printing. All test objects are printed, and these with the brick layers are marked with letter B on the top. I will just measure the weight of few test objects, always first regular and then the brick layers. I will speed up this part, but you can see the table with measured values. These are in grams. And that multiplier on the moved layers increased the mass by approximately 4%. So the mass advantage is on the brick layers, but why don't we just increase the flow rate with the regular printing too? Well, take a look of these side surfaces. They are equal, but here if I would increase the flow rate, it would be very ugly because we don't have the space for that extra material. The tensile test with horizontally printed test objects. And now brick layers. And these are stronger. The hook tests side by side 2 printing methods, and brick layers are stronger again. The ISO impact test, and with this unit I can measure only higher impacts, so that's why these are 6 mm thick instead of 4. 140. 139.5 maybe. The measurable difference with this unit is extremely minimal between these 2 printing methods. 3-point bending test. Distance between supports is 64 millimeters, very close to that ISO standard. And I will just place this 5 kg load and I will measure the deformation after exactly 30 seconds. Side by side, placing the load on them. And after 30 seconds, less deformation on the bricklayer version. So far everything as expected. Bricklayers are better in every test so far. That extra material really helps with the strength in X and Y direction, and this is almost independent from the layer adhesion. So all I have to do is few layer adhesion tests and I'm finished. I thought so. Let's start with 4x4mm test object, and this was printed with regular method, normal flow rate. 58.5 the average value, and with the bricklayer I printed one with the same multiplier, and this was slightly weaker. And this was printed with 1.1 multiplier, and this was noticeably stronger. Side by side, two printing methods. And these are printed with 6 walls and 15% infill, regular method. Bricklayers printed with the same flow rate, slightly weaker again. And the maximum of this scale is theoretically 200 kilograms, or just slightly above it. I hope I will be able to break these. And 1.1 multiplier. Well, it definitely increases strength. These are bricklayers, and looks like it is not so obvious that they will be stronger every time. Definitely something I have to recheck, and I will reprint these test objects with a 0 infill and maybe less walls. So what's going on here? This is just a theoretical look of the layers. In reality they overlap much more here, but with this it will be easier to explain. As we can see, they have a contact here, but if we move the layers, in that case we have here this gap. In reality we still have the contact, but it will be smaller. So this means that not only that we can, but we must increase the flow rate to have a better contact. Maybe it would be better to increase the flow rate on all layers, not only moved ones, or maybe just disable on outer wall and of course on infill. So this is something which has to be investigated more. Switching to Sunloop PLA Plus 2.0, this one is in orange color. Just a small note, with previous testing I used these test objects with a diameter of 10 millimeters because I was expecting here bigger loads with 6 walls. And his second part, I forgot that, so I used this one with the cross section of 10 by 10 millimeters. And even if it was printed with 4 walls, you will see it was quite strong. But for comparison testing, this will not affect the result. Definitely need a better experimental plan here, but this will be much bigger work now. So these test objects are printed with 4 walls and 0% infill. I had to reduce number of the walls because it's too hard to break them and I have the maximum of my scale. Now this is the reference material printed regularly, and these are bricklayers with multiplier from 1.1 up to 1.4. Now there's a problem with this script because it don't modify the outer wall. So this means from these 4 walls only one is modified by that moving and by this multiplier. And also I measure the weight in groups of 3. Later I will analyze the numbers. And I have a small correction here. With this G-code analyzer, it looks like only one layer is moved, but 2 of them have a higher flow rate and one of them is the outer wall. Maybe it is not moved at all, and I'm not really sure if this is the proper method. It is okay that outer wall shouldn't be touched, but I think this bricklayer should start from the second wall, counting from outside. And then I have these test objects. Smallest cross-section area is 4x4 millimeters. This is the reference material printed regularly, and then I have bricklayers with a multiplier of 1.0 up to 1.5. I also check what is the maximal multiplier in both cases. With bricklayers I could go up to 1.7. It crosses up so much because of the extra material that this was moved from the bed, and this is a failed print. Also I check with regularly, this is 1.2 multiplier, but don't forget here it modifies basically all layers. And actually this is on the edge of printability because it also curls up a lot because of the texture material. Just for curiosity, this was printed with the bricklayers 2.0 multiplier, and even on the side surfaces we can see a lot of extra materials. This means with these 4 test objects too, I will have 47 testings. That's quite a lot. Here I also measure the weight in group of 4s until they are connected, so let's see those numbers. This test object is 10 by 10 millimeters here, and it was printed with 4 walls and 0% infill. And this is a reference material printed with normal 1.0 multiplier, and these are all brick layers from 1.1 up to 1.4 multiplier, and we can see nice increase in the mass. And then this test object is printed with 5 volts. This means it is solid inside because smallest cross-section area is 4 by 4 millimeters. And this is the reference material, and these are brick layers, and this one is printed with the 1.0 multiplier, and theoretically these two should have the same weight, and basically the difference is extremely minimal. And then we can see nice linear increase in the mass here. These are those smaller test objects, and you can follow the average results on the left side of the screen. Before I continue, I have to clean up this mess. Bigger test objects with 4 valves and 0 infill. Oh, what a mess again. With the smaller test objects, we can clearly see the correlation between the multiplier and the strength. This is 1.7, just for curiosity. Now, this irregularly printed with normal flow rate had a similar strength like with the brick layer 1.1 multiplier. But with these bigger test objects with 4 valves and 0 infill, here actually it was significantly stronger compared to the regular and 1 multiplier. But the rest of the brick layers, we can see clearly again that correlation between the multiplier and the strength. Overall, the results are promising, but using brick layers makes sense only when combined with the proper multiplier. I don't know which work was bigger, the testing or the video editing, but huge thanks to my Patreon supporters because they keep me motivated to do this kind of big work too. If you're not familiar, I don't earn too much from the YouTube ads, basically. And if somebody will write me again that for this kind of video editing I need only 4 hours, he will get a job, but I'm paying only 4 hours. About these brick layers. It looks like this script is not completely finished, but at least we can do some testings, and I believe that it will be modified. And it is important because with this kind of prototyping and testing, those slicer manufacturers and programmers will have more information, so they can optimize better that code integrated into Slicer. Now, as it is in this state, I don't think I will use it, but I hope that soon it will be optimized and integrated into Slicer. But I hope this problem with the patent will be solved in very near future. I don't know, what's your opinion about this? Anyway, thank you for watching and happy printing.